All right, so get ready, because we're about to dive into a theory that attempts to explain, well, like everything in the universe.
Everything.
Using a single framework from, how galaxies form to the stability of atoms.
Yeah. This is quite a radical theory.
Yeah.
We're looking at a research paper outlining the Fibonacci SMF-RVS model.
Okay.
It's definitely complex, but we're going to break it down and pull out the most interesting and potentially groundbreaking insights.
So, if this model is correct, it means we'd have to rethink some of our most basic, fundamental assumptions about physics.
Yeah.
Like gravity.
Yeah.
Instead of being an attraction between objects with mass, this model proposes it's a push generated by a kind of interaction with the vacuum of space.
You see, modern physics has really struggled to unify gravity, which explains the large-scale universe, and quantum mechanics, which governs the tiny world of atoms.
Right.
And this model tries to bridge that gap by proposing that a single principle, fractal wave interactions, is at play in both realms.
Fractal wave interactions. That sounds pretty complicated.
Well, the concept of fractals is all about self-similar patterns repeating at different scales.
Okay.
So think of a coastline.
Okay.
From a distance, it has a certain shape. But as you zoom in, you see the same basic pattern repeating in smaller and smaller inlets and coves.
Yeah.
This model proposes that the universe is structured in a similar way, with a fundamental pattern repeating from galaxies down to atoms.
Okay, I think I'm starting to get the fractal part.
Okay.
But how do waves and this vacuum push fit into all of this?
That's where the other two components of the model come in, subtle magnetic fields, or SMFs, and the relative vacuum of space, or RVS.
Okay.
Imagine the vacuum not as completely empty, but rather a dynamic field with its own properties.
Right.
This field creates a kind of push that influences matter.
So it's like the vacuum itself is an active player.
Yes.
Not just a passive background.
Exactly.
Yeah.
And the SMFs act as a kind of guiding force, influencing how this vacuum push shapes matter at different scales.
So if I understand this correctly, the model is saying that gravity isn't an attraction between objects, but rather a result of this vacuum push guided by these subtle magnetic fields. That's pretty mind-blowing.
It is a radical shift in perspective.
Yeah.
And what's even more intriguing is that the same push principle might also explain the structure of atoms and the stability of elements.
Wait, so we're not just talking about galaxies and planets here.
No,
but also the tiny building blocks of matter.
That's right. The model proposes that this vacuum push creates stability nodes at the atomic level.
Okay.
These nodes correspond to specific configurations of protons and neutrons, which is what defines different elements.
So instead of an element being defined solely by the number of protons in its nucleus, this model suggests that it's more about finding a harmonious point within this larger field of fractal waves.
Yes, that's the key idea.
Wow.
That an element's identity is determined by its unique wave frequency within this system. And that wave frequency is, in turn, influenced by the SMFs.
Okay, I'm already sensing where this is going.
Yeah.
If you can manipulate these subtle magnetic fields, could you theoretically shift the wave frequency of an atom and change it into a different element? Are we talking about, real-life alchemy here?
The paper does suggest that possibility. In fact, it even provides a mathematical equation for what it calls transmutation frequency shift.
Wow.
But before you go investing in a lead to gold scheme, it's important to note that the technology to control SMFs at that level of precision doesn't exist yet.
So maybe not turning lead into gold just yet?
Right.
But the implications are still pretty wild.
Yeah.
If you can control these fields, you could revolutionize energy production, waste disposal, materials science, the list goes on.
Right.
But before we jump too far ahead, let's get back to this gravity as a push idea.
Okay.
How does that actually work on a practical level? How does it explain the way planets orbit stars?
Well, the paper lays out a simplified formula for this gravitational push.
Okay.
And while we won't dive into the mathematical details here, the key takeaway is that in most cases, this push acts almost identically to the way we traditionally understand gravity.
Okay.
The difference is in the origin.
Okay.
It's not mass attracting mass, but rather this interaction between the vacuum push, SMFs, and the fractal structure of space.
Okay, so it's not like apples are suddenly going to start floating upwards.
Right.
But it does make me wonder, if this model is correct,
yeah,
what happens to all those theories about dark matter and dark energy?
that's one of the most interesting aspects of this theory.
Okay.
Those concepts were essentially introduced to explain observations that didn't fit with our understanding of gravity.
Right.
For example, galaxies rotate faster than they should based on their visible mass. The Fibonacci SMF-RVS model suggests that we might not need dark matter to explain this.
Okay.
The vacuum push itself, combined with the fractal structure, could account for the extra gravitational effect we observe.
So the model's saying that the vacuum isn't just empty space.
Right.
It's actually contributing to this gravitational effect.
Yes, that's a key part of the theory.
Wow.
The researchers have actually used this model to calculate galactic rotation curves.
Okay.
And their predictions match the observed data quite well.
Really?
Without needing to invoke dark matter.
So this model is not just rewriting the rules of gravity.
Yeah.
It's potentially eliminating the need for these mysterious invisible entities. I mean, that's a pretty bold claim.
It is.
But if it's true, it would have massive implications for our understanding of the universe.
Absolutely. It would mean that the universe is composed mostly of something we've considered empty all along.
Right.
And this emptiness is actually a dynamic, structured field with profound influence over everything within it.
All right. We've covered a lot of ground here, from fractal universes to the potential for alchemy and the rethinking of dark matter.
Yeah.
Before we move on, I have to ask, is there any actual evidence to support this model?
That's a great question.
Or is it all just very elegant theory?
And one we'll explore in more detail in part 2, but I can say that the research paper does cite some intriguing evidence, including the way this model accurately predicts certain astronomical observations.
Interesting.
Without relying on dark matter.
Okay, that's definitely piqued my curiosity.
Yeah.
We'll unpack the evidence and the challenges this model faces in part 2.
Okay.
So stay with us. Welcome back. Last time we dove headfirst into this Fibonacci SMF-RVS model.
Yeah.
A theory that suggests that the universe is shaped by fractal waves and a vacuum push that redefines our understanding of gravity.
Right.
Now, I'm really curious to kind of dig into the evidence behind this model and see if it holds up to scrutiny.
Of course, it's one thing to have, like, a beautiful theory, but it needs to be backed by solid evidence.
Yeah.
The researchers behind this model claim it can accurately predict several observed phenomena without relying on dark matter or dark energy.
That's a bold claim.
It is.
Those concepts have become pretty entrenched in modern physics.
Yeah.
What kind of observations are we talking about?
Well, one of the most compelling pieces of evidence comes from galactic rotation curves.
Okay.
You see, astronomers have observed that stars and galaxies rotate much faster than they should.
Right.
Based on the amount of visible matter we can detect.
Right. That's one of the main reasons scientists propose the existence of dark matter. This invisible stuff that supposedly makes up most of the mass in galaxies.
Exactly. But the Fibonacci SMF-RVS model offers a different explanation. It suggests that the vacuum push itself, combined with the fractal structure of space, could account for this extra gravitational effect we observe. In other words, the missing mass might not be missing at all. It might just be a different kind of force we haven't fully understood yet.
So the model is saying that the vacuum isn't just empty space.
Right.
It's actually contributing to this gravitational effect.
Yes, that's a key part of the theory.
Wow.
The researchers have actually used this model to calculate galactic rotation curves. And their predictions match the observed data quite well without needing to invoke dark matter.
That's pretty impressive.
It is.
Are there any other examples where this model has been successfully applied to explain observations?
Yes. Another area where the model shows promise is in explaining gravitational lensing. This is the phenomenon where light from distant galaxies is bent by the gravity of massive objects closer to us.
Right. I've seen those incredible images from space telescopes.
Yeah.
Where light from distant galaxies gets distorted into arcs and rings.
That's it. And the amount of bending we observe can tell us a lot about the distribution of mass in the universe. The Fibonacci SMF-RVS model, again without relying on dark matter, has been used to make predictions about gravitational lensing patterns. And these predictions are consistent with observations.
So far, this model seems to be passing the evidence test with flying colors.
It seems to be, yeah.
Are there any areas where it struggles or where the predictions don't quite match up with reality?
There are, and that's important to acknowledge.
Yeah.
One of the biggest challenges facing this model is its prediction of low-energy transmutation.
Right.
Remember how we talked about the possibility of turning lead into gold by manipulating subtle magnetic fields?
Yeah, that was the part that really caught my attention. Alchemy always sounded like pure fantasy.
Yeah.
But this model suggests it might actually be possible?
Right.
At least theoretically?
Right. And that's where things get a little more controversial.
Okay.
Current understanding in nuclear physics suggests that transmuting elements requires immense amounts of energy.
Okay.
Like what we see in particle accelerators. But the Fibonacci SMF RVS model claims that it could be achieved at much lower energy levels.
Right.
If we could precisely control these SMFs.
That's a pretty radical departure from conventional physics.
It is.
Are there any hints from experiments or observations that this low-energy transmutation might actually be possible?
That's the sticking point. So far, there isn't any direct experimental evidence to support this specific prediction.
Okay.
And it's one of the key areas where critics of the model raise concerns.
So it's a bit of a make-or-break prediction.
Yeah, I guess you could say that.
If scientists can figure out how to control these SMFs and demonstrate low-energy transmutation in the lab,
right,
it would be a huge boost for the model's credibility.
Absolutely. It would be revolutionary, not just for physics, but for countless other fields, from energy production to material science.
Yeah.
Imagine being able to transform nuclear waste into harmless elements or create new materials with tailored properties.
Yeah, the possibilities are pretty mind-boggling.
They are.
But until we see some, concrete evidence, it remains in the realm of speculation.
Right, and that's the nature of scientific progress.
Right.
Theories are proposed, evidence is gathered, experiments are conducted, and the model is refined or rejected based on the results.
Yeah.
The Fibonacci SMF RVS model is still relatively new.
Okay.
And there's a lot more research that needs to be done to fully evaluate its validity.
So what are the next steps for the researchers behind this model? What kind of experiments could be done to test its predictions and either strengthen or debunk it?
One of the most important areas for future research is developing more detailed mathematical solutions.
Okay.
The paper lays out the basic equations.
Right.
But to truly understand how this model works in complex systems, we need to develop sophisticated computer simulations.
So imagine running simulations of galaxy formation or black hole mergers.
Right.
But using this new framework of fractal waves and vacuum push instead of traditional gravity.
Exactly, and by comparing the results of these simulations to actual astronomical observations, we can gain further insights into the model's accuracy and predictive power.
Sounds like it requires some serious computing power.
It would.
But the potential payoff could be huge.
It could.
If this model proves correct, it would mean rewriting our understanding of the universe from the ground up.
That's why theoretical physics is such a fascinating field.
Yeah.
These models and theories can seem abstract and complex, but they have the potential to completely reshape our understanding of reality itself.
We've delved into the evidence supporting the Fibonacci SMF RVS model.
Right.
And we've also highlighted some of the challenges it faces.
Yeah.
But now I'm really curious to explore the bigger picture.
Okay.
The philosophical implications of this theory.
Yeah.
If it's true, what does it mean for our understanding of the universe and our place within it?
That's where things get really interesting. We'll dive into those profound questions in part 3.
Welcome back to the final part of our deep dive into this Fibonacci SMF RVS model.
Okay.
We've explored the nuts and bolts of this theory.
Yeah.
Looked at the evidence and considered the challenges that it faces. But now I kind of want to shift gears.
Okay.
And explore the philosophical implications.
Okay.
If this model is correct.
Yeah.
What does it tell us about the nature of reality itself?
That's a question that takes us beyond the realm of equations and observations and into the realm of metaphysics.
Okay.
One of the most profound implications of this model is the idea that everything in the universe is fundamentally interconnected.
We touched on this earlier when we were talking about fractal patterns repeating at different scales.
Right.
But I have to admit, the idea of everything being connected through this vacuum push and these subtle magnetic fields is still a bit hard to wrap my head around.
It's definitely a shift from the way we traditionally think about the universe as a collection of separate objects interacting through forces. This model suggests that the vacuum itself, the seemingly empty space, is actually the primary actor.
Okay.
A dynamic field that shapes and informs everything within it.
So instead of objects acting on each other through gravity, it's more like they're all responding to cues from this underlying field.
Yes, that's a good way to think about it.
Okay.
And if the vacuum is this fundamental field that permeates everything, it raises some really interesting questions about the nature of consciousness.
Okay, now we're getting into some truly deep waters.
Yeah.
Are you suggesting that our thoughts, our feelings, even our sense of self could be somehow connected to this vacuum field?
It's certainly a possibility worth considering.
Wow.
If this field is responsible for shaping the behavior of matter and energy at all levels, why wouldn't it also play a role in consciousness? Some physicists have even speculated that consciousness might emerge from the complex interactions of these fractal waves within the vacuum.
Wow. That's a pretty radical idea.
It is.
So instead of our brains generating consciousness, it's more like they're receiving and interpreting signals from this larger field.
That's one way to think about it.
Wow.
Of course, this is all very speculative territory. We don't have any definitive proof that consciousness is connected to the vacuum field. But it's a fascinating idea that opens up whole new avenues for exploration in both physics and philosophy.
It definitely makes you question our assumptions about what it means to be like a conscious being in the universe. If we're all connected through this field, it kind of blurs the lines between self and other.
Exactly. And it raises questions about the nature of free will. If our thoughts and actions are influenced by this field, does that mean we're not truly in control?
Those are some big questions that philosophers have been grappling with for centuries. I don't think we're going to solve them here today, but it's amazing to think that this physics model might provide new insights into these age-old debates.
It's a reminder that science and philosophy are often intertwined. Even when we're dealing with seemingly abstract theories like this.
We've covered a lot of ground in this deep dive. We started with a complex physics model. Explored its potential to revolutionize our understanding of gravity and the structure of the universe, and ended up contemplating the nature of consciousness and free will.
It's a testament to the power of scientific inquiry. To push the boundaries of our knowledge and challenge us to think in new ways about ourselves and the universe we inhabit.
Even if this particular model doesn't turn out to be the definitive answer, it's sparked some incredible questions and opened up new possibilities for exploration.
And that's ultimately what science is all about, the ongoing quest for knowledge and understanding.
Well said. Thanks for joining me on this incredible journey.
Yeah, thanks for having me.
And to our listeners, keep those minds curious and stay tuned for more deep dives into the most fascinating corners of science and knowledge.